A car is traveling at 20 meters per second when the driver sees a child standing in the road. Uh-oh. He takes 0.8 seconds to react, then steps on the brakes and slows down at 8 meters per second squared. How far does the car go before it stops? I think I would probably underline the physics word stops, and I would make a note of slowing down, and then I would start over here. I think for this question, Aiden, I think there's 2 trips. Similar to what we did on the slide question, but I'm going to draw a little picture. Here's the car. Here's the kid. I think the car coasts for a while. Let's say it's that far. That's how far the car travels before the driver hits the brakes. That's the reaction time. I'll call that coasting, because you're not speeding up or slowing down. Then, braking. And just like that, I've kind of divided my page into 2. I'll do that and just kind of extend the drawing. I'm going to read the question, and I'm going to very, very carefully look for physics words and numbers, and I'm going to put them into either the coasting section or the braking section. Car is traveling at 20 meters per second. Y'all agree? I think that's VI coasting, yes? What's that 0.8? What's that 0.8? What are the units next to that 0.8? So, time. Is that time after we hit the brakes or before we hit? Okay, so it goes here. Slows at 7 meters per second squared. That's an acceleration. Why would this be wrong? Yeah. I have to insert a negative here. Okay. How far does the code stops? It wants to know how far. I think I'm going to find how far the car traveled while coasting. I'm going to abbreviate, if that's okay, Cohen. I'll call that D with a C. I'm going to find how far the car traveled while braking. And then I think the total distance is, I'll add them up. Cohen, how many things do I know here? How many things do I know here? I need 3 to find a 4th. So I'll pause. Did anybody see there's something else we know here that's kind of implied? Did anybody catch it? Has the driver hit the brakes in this section right here? Say no. Have they stepped on the gas and sped up in this section right here? What's their acceleration right here if they haven't hit the brakes or sped up? A is 0. I know 3 things. Now I can use D equals VIT plus a half AT squared. Similar to the one we just did on the quiz, but instead of VI being 0, A is 0, which means that whole thing will just vanish because a half times 0 times T squared is just 0. The distance is going to be 20 times 0.8, whatever that is. That's how far the car travels before the driver has a chance to hit the brakes. Santa, you okay with that? Okay. Santa, how many things do I know here? I need 3. Or do I know 3? Well, it's a good question. Clody, how fast was the car traveling? I'll use my eraser right here. What was VI? Are we speeding up or slowing down? Say no. So how fast are we still traveling right here? How about right here? How about right here? How about right here? How about right here? How fast are we going right here? How about right here? How about right here? How about right here just as we hit the brakes? Loud and proud. Do you know what VI is when we start to hit the brakes? It's still 20 because we haven't hit the brakes yet. That's what we started at, and now we'll start braking from that speed. Now I'm looking for an equation that's got an A, a VF, a VI, and a D in it. I think it's going to be this one. D equals VF squared minus VI squared all over 2A. I was very bold. I got the D by itself from the VF squared equals VI squared plus 2AD equation. And your final answer, you'll add those both up. Eric, if you want an application, actually they would use the same physics to figure out where do we have to put the stop sign warning sign far enough away so the driver has time to react to know that there's a stop sign coming up and start to hit the brakes. Oh, and then they'd add a bigger margin because drivers are not very smart sometimes. Rain and things like that, right? So that's where what was the correct answer? I don't know. That's where the 44.6 came from. That should work. Okay. Today, cool lesson. We're going to talk about G's. G's! No, I mean G's in physics.